Okay, we're going to continue on with operations with fractions. In your high school career, anytime you're dealing with fractions, you will find you will never work with mixed fractions again. And so, although this lesson is going to get you to work with both, its main focus is to show you how to turn it into an improper and then use improper to add and subtract. The bottom line is this: when you're given mixed fractions, before you do anything, turn it into an improper, please. Okay? You will never, ever have to deal with mixed fractions ever again, literally for the rest of your life. Even if you use math in your career, you will not be working with mixed numbers. You won't. Okay? As a recap, we can work with A and C. It's on this table. Sorry, I moved it while I was talking. There you go. Very quickly, if you want to work with fractions, you need the denominator to be the same. So I'm going to show all my work, no mental math. -4/5, I need the denominator to be 15. And so I'm going to multiply it by a 1. Plus 1/3, I'm going to multiply it by a 1. Leaving us with a -12/15 and a +5/15. Well, a -12 positive. Hello. Way too excited. Give me a sec while I diffuse. Oh, we got it. So much. It's good to be done. Yeah. Oh, shoot. No. All right. So if you can do that, I'm pretty sure you can do the rest of it. I'm not going to insult your intelligence. I just want to remind you once again, a negative, it's just a symbol. Okay, if you want, get that out of the way and start working with common denominator. It's on that table. Sorry, Andrew. Can you bring that pile back to the main table? Yeah, I just moved it while I was there. And of course, there's more to be done. Okay. Hint, the common denominator is going to be a 36. So you figure that out. Mixed numbers. If you know how to add and subtract, you're basically done half the lesson. The other half is making sure you know how to work with mixed numbers. Now I'm going to give you another example down here, so leave some space, but this is how it works. If we have 2 and 3/8, what does that actually mean? Well, I'm going to draw 2 holes and 3/8 of a pizza. Take a look. That is a sweet circle, by the way. Let's see if I can do it again. Not bad. So here are 2 whole pizzas and then another 8. I'm taking a blue because I think it comes out nicely in this video. 2 holes means I have 8 pieces here, fully accounted for. I have another 8 pieces here, fully accounted for. And then I have 3 out of these pieces. With me so far? All right, my children, let's count the pieces together. 1, 2, 3, 4, 5, 6, 7. Okay. I can't keep it up. It's so embarrassing. 8. We have 8 pieces here. 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces here. 1, 2, 3, 3 pieces. How many 8 slices do I have? 8 plus 8 plus 3. 19. And that's why we say, if the slices were cut into eighths, I have 19 pieces. Does that make sense? But instead of adding 8 plus 8 plus 3, instead of adding and adding and adding the same number, what's a shortcut for adding? Multiplication. So if I have 2 wholes, that means I have 2 8 pieces. So that is why when you see a large whole number, you multiply that by how many pieces each pizza has, and then you add it to the fraction that's left over. So we have a multiplication and then an addition. Okay. So as an example, this would be, let's do it in your head, 2 times 8 is 16. So I'm doing this part right here, okay? That's a 16. And then that 16, where's my green? Where's my green? Then that 16 is going to be added to the top. So that 16 is going to add the top, giving me 19 over 8. Plus 1 whole. How many slices? 1 times 8, once again. So that's 1 times 8. That is going to be added to the 5. I should have 13 over 8. And if I can do that, and using a calculator, I can add the numerator. That becomes 32 over 8. Which can be reduced. I guess you gave me something, Miles. Yeah. Divide both top and bottom by 8, or 1. The final answer is a 4. Yes, thank you.
You also add small fractions and add big numbers at the end.
You can. However, there may come a time where even that becomes annoying. And plus, the whole goal of today is to never deal with mixed again. I want everything to be done in improper. And just in case it doesn't become a nice whole number, just turn it into improper anyways. If we become pleasantly surprised, we become pleasantly surprised, but always turn this into that. One issue that some of you might have, and another math teacher caught it and let me know, so I'm going to tell you right now. What if I have a negative mixed number? Now, this is not a deal because negative times negative becomes positive, right? So this is 3, 2 over 4, plus 2, 3 over 4. But what if it was actually just a subtraction? What is the mixed value? So let me do an example, okay? Leave this here, we're going to solve it after. But as a separate example, I want you to create a little box and say, watch out. What if you had a negative 2, 3 over 8? Okay, so it's the exact same as here, but it's a negative. Lev? Yeah. So that becomes what, negative 16? Is that what you're thinking? And then you add it to a 3? Maybe. Anything. Oh. Right. So some people might say negative 13. Abby, what about you? Maybe. Maybe there's a relationship between adding and multiplication and division and subtraction. The actual answer is this. You know how this is positive 19 over 8? I know, okay? Think about it in terms of money. It's the easiest. If you owe someone $2 and 30 something cents, I think this is like 31 cents or something, okay, or 37 cents. It should equal this much. But some people might do this. Some people might have taken the negative and then multiplied it with the 2, multiplied a -2 with the 8, and then assumed the 3 was a positive. So it's +3 and -16. That's actually incorrect. Let me try to explain. The negative tells you how far away from the 0 we are. It's not that it's a -2 with a +3/8. This is not -2 plus 3/8. It's not that. It's not separate. So 2 and the 3/8 is together, and all of that happens to be a negative. So if you want to think about it in one way, that -3 is just as negative as the whole 2. So you could think about it as this. -2 3/8 is the same as a -2 put together with a -3/8. You could think about it like that. Another way you could think about it is -2 3/8 is the same as a negative value of 2 3/8. All I'm trying to say is this number, this fraction is together. They are all negative together. So pretend the negative isn't there. Just solve it as is and then multiply it by a -1, if that makes it easier for you. But I understand where the confusion might come from. So please be careful of that when you're using mixed fractions. Once you get the hang of it, and once you get that into muscle memory, you won't even have to worry. It just becomes common knowledge, and you just do it in as part of the questions without stress. But I mean, who are we to just say, oh, we got it, we don't got it? Might as well just practice to make sure we can give ourselves some confidence. Okay, I am going to leave this because we're going to be doing more practices, but you can finish on your own. All right, like all of this, you can finish on your own. Let's take a look at the back of page 1. And we shall do this together before we move on to some of the word questions. Here we go. I have a question with fractions dealing with different kinds of numerators and mixed fractions. Step 1, change it all into improper fractions, please. 1 times 3, I have 3 pieces. Added to 1 I already have. This becomes 4/3. 2 times 4, I have 8 pieces in my hands. I'm adding it to the 3 that's already there. So I'm going to write the minus already. I have 1 times 8, that's 8 pieces, adding to the 5 I already have. But that value is actually on the left side on the number line. So it's a negative. It's a negative. I don't know how I can explain it that makes sense to each and every one of you. Well, it's a negative. This is a negative fraction. So, well, yes, you can think of this as adding a negative or subtracting a positive fraction. Sorry. Either one is the same. Adding a negative or subtracting a positive, same thing. All right, that was one big step. Probably give you a full 1 mark on a quiz if you did that successfully. Next mark, the denominators have to be the same. So if you don't want to follow me, but you want to try it yourself, go ahead. But I'm going to say that the denominator is not a 4, 8, 16, 24. Who here would still like me to show every single step just to make sure you know what I'm expecting? Okay. So we've got 4/3. I need to turn that into a 28. I have a 11/4 that I'm trying to turn into a 28, so 7. And I have a 13/8 that needs to turn into a 24. Whew. That becomes 32. Oh, whoa. That's a 28, not a 24. My bad. That should be a 6, 6/6. Sorry. Sooner or later, you're gonna get comfortable with me and start cussing me out. Please don't cuss me out. I'm human too. So if you have all the denominators the same, yes, it's messy at first, but it will clean up. Let's do BEDMAS by adding the brackets first. 66 minus 39, 30, 27. And you add that, that becomes a 59. And done. So something like this, changing from mixed to improper, and then getting the same denominator, and then getting the final answer. This is probably anywhere from 2 to 3 marks easily, minimum. Okay. All right. Any questions? We're pretty much done. As a way to practice, I'm essentially going to give you 2 word questions before you try some of these for weekend homework, which is important as usual. Okay, so there's more examples here you can try. I hope you will be successful in them. As once again, if there are questions, reach out to me through email. I will do my best to respond. If your question is too complicated, I may even create a video for you so I can help you better over the weekend.
Where should we answer these questions? Where should we answer these?
Oh, just right here in the same piece of paper. Take a look. In real life, it sometimes makes sense to express answers as mixed numbers. So we're going to go backwards, all right? Here. A carpenter is cutting thin sheets of wood to build a small jewelry box. She accidentally cuts the bottom panel too big. Its current dimensions are width of this, a length of this. The correct dimensions of the bottom are 15/16 less than the current dimensions. What are the correct dimensions expressed as a mixed number? Right? So there are times where mixed numbers are needed, like inches and feet. Sometimes fractions make sense. But in the world of math, you won't have to ever use it again. Here we go. Width is currently 4 5/8. I need that dimension to be 15/16 less than what we have right now. What is that equal to? Okay. So what I'm going to do turn them into mixed fractions, turn them into improper, and then try to solve it out, okay? You can do length on your own. I'm gonna try to do this with you. 4 times 8 is 32 pieces. Adding on to the 5, it's 37 pieces out of the 8. And I have 15 pieces out of 16 subtracting. Next, when you're subtracting fractions, you have to make the denominators the same. Maybe I'll make a little note. Step 1, improper fractions. Step 2, common denominator. So 37 over 8 is multiplied by 1. And this becomes 74 over 16 minus 15 over 16. That's 64, 59 over 16. How do I turn that into a mixed? How did your teacher show you from last year? You just divide it separately? Because I have not worked with mixed fractions in such a long time because it's never seen in high school. So I want to know what you're used to.
Well, here, was in the 9 over, and yeah.
Okay, so we're gonna have to do some side calculations, huh? So 16 times 3 is 48, and then 16 times 4 is 56, and 16 times 5 is 64, sorry. And 16 times 5 is 80. So I don't have to do this. 64 is already way too big, which means I could only have 3 wholes. How much is left? Yeah, 59 minus 48 pieces that are gone, we've got 11. Here's your answer for width. Using the same process, can you do length for me? The length was given as 2 and 14, and we need that to be smaller by 15/16 of an inch. Let me try that. I'm going to pause this video. I'm going to start recording. So it seems that a lot of people still would like a bit more written practice on this, because when I threw you in the deep end, you're like, I still don't understand what the heck is happening. Let's go back. Let's go way back. Let's start with the front page. I jumped the gun. Let's finish this together. I totally assumed that I did it once and you can probably repeat it again. That was the wrong assumption. Let's try this together. It was the very front page. We're going way back to the front where I did the little pieces and I showed you what you shouldn't do. I threw way too much information at you. Let's do this one step at a time. So the question given is, here's a mixed fraction adding to another mixed fraction. You probably learned how to deal with that already, but I am forcing you to change this into a improper. Okay, so little star, first thing I want you to do is change this into improper fractions. How do we do that? Pay attention here, everybody. Whole number, just like the little example I gave. The whole number will tell you how many of these fourths I have. So 3 times 4, 12. I have 12 pieces adding to the 2. I have 14 pieces if each piece is cut into 4. That's what the first fraction adds up. Same as before. Your goal is improper fractions, improper fractions. So take your whole number, multiply it with the denominator, which will tell you how many pieces you're dealing with. And then add it to the 3 you already have. So the 2 wholes means I have 8 pieces on top of the 3 I already have. This mixed fraction becomes 8 plus 3, 11 over 4. Every single time you get a mixed fraction, I want you to do this. So we'll try it again in the next question. Let me finish this off. You add this together. This is 25 over 4, done. I don't need you to change it anymore unless you can reduce it. In this case, you can't. Let's keep doing it again and again. I'm going to turn the page and try the first example on the top. Yes? Yeah, go for it. Let's do it again. Keep at it. This question right here, the first one. First, adding a negative. That's essentially the same as this. Okay, I have this number and I'm subtracting that number. Step 1. What's step 1? Yeah, improper. So 3 times 5, and then 1 times 10, of course. 3 times 5 is 15. Add that to the 4 pieces you already have. This becomes 19 over 5. And notice I'm not multiplying a negative one. I'm just multiplying the 1 itself. You can avoid confusion. Leave the negative alone. 1 times 10, 10. That's 10 pieces. Add it to the 7. What's that? Now we can subtract, except, ooh, we can't. What did I not do yet? Continue on. You got it? No? Something. I forgot to do something. I can't subtract it yet. Jamie? Yeah. I'm going to say denom. Can't do it. We're talking about completely different sizes right now. So I'll show every step. So 5 needs to be multiplied in this way so that the denominator is a 10. Here we go. So 19 times 2 is 38. That's a 10 minus 17 over 10. Just to highlight this for future reference, right? That's the new part. We're multiplying by a 1. And the final answer, you ought to be able to work out slowly. Okay. And so with that, this becomes 21 over 10. And that's all you need to do. I am going to go to the bottom example now with this carpenter thing and try to show you another example to prove these word questions are literally the same questions you've done above, but you first have to read and make out the numbers and figure out what they're asking for. That's the hard part. Are you able to apply it in a story situation? Oh, I don't have much time. Here we go. Step 1. Abby? Well, yes, we did. Now, what's next? Okay. Trevon? Yeah, what's next? So again, improper. Turn it into improper. So I am going to get rid of that whole number. 2 times 4 is 8. That becomes 9 over 8 minus 15 over 16. Okay, I'm ready to subtract. Except, yes, good catch. Just testing you. Sorry about that, really. Didn't mean to do that. So I'm ready to subtract. Except, Miles? Yeah. So the next thing is com and yeah. So 9 over 4 is multiplied by a 1, which gives you 36 over 16 minus 15 over 16, which you will solve as 21 over 16. And I would be finished with my lesson or with my question, but it did ask for mixed fractions. I shouldn't have put it in, or I should have taken it out rather. So no, 16 times 1 is 16. Anything larger than that goes way above 21. So this actually equals 1 and 5 pieces are left.
1 and 10 over 32.
Yes, but it's not lowest terms. You have to reduce it. I'll write it again. 1 10 over 32. I can divide top and bottom by a 2. So that would be a communication mark, reducing. I saw a hand, I think it was Abby, yeah? You sure? Yeah. It might be worthwhile mentioning. So that's it for today. Again, Abby, if you have something, just let me know. You can send an email or talk to me privately. Every single one of these questions, even this, even subtractions with gingerbread cookies and stuff, if any of you cook or bake, you know that all the spoonfuls and whatnots come with like 1/4 cup of this, 1/2 cup of that, and it can be really annoying, right? So here's an example of it. The States loves to use, like the US, loves to still use fractions and imperial measurements, which uses a lot of fractions for whatever it's worth. So yeah, it is what it is. The rest of the sheet, along with some of the questions in the back, it's literally a repeat of everything we've done. I would like you to do it for class and homework for this weekend. Okay. It is a lot of work, it is, but we have done most. You have one question here, one gingerbread question, and do as many of these. I highly recommend you tell yourself to do 5 questions today, 5 questions Saturday, 5 questions Sunday. This will be done if you do that. It's a suggestion. Yes, love?
The question 8
Ha 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 ha. You're right. That was definitely a mistake, but yay, less work for you, I guess. Okay. Okay, let me pause this.